Lesson 2-4, Day 1. Solving equations with the variable on each side. Our essential question is, how do you solve an equation with variables on each side? We have no new vocabulary today. We have two steps that we're going to focus on. The first step is going to be to get the variables on one side, because we're trying to isolate the variable, which means get it by itself, so we can't do that when there's more than one of them. So when you see more than one variable, you need to get them all to one side of your equation. And then the second step says solve the resulting equation, because the resulting equation is going to look different each time. It's typically a two-step or one-step equation though, so it should be something that you're already familiar with. Our first equation to solve is 8 plus 5x equals 7x minus 2. So I'm going to draw my line to separate the two sides of my equation. And I'm going to look at those variables, 7x and 5x. They're both positive variables, and it's your choice which side you want to move your variables to or which one you would like to eliminate. My general rule is that if possible, I like to eliminate the smaller one to keep my variable a positive. So the smaller variable in this situation is the 5x. So I'm going to choose to subtract 5x on each side. So then my resulting equation is 8 equals 2x minus 2. Now this is a two-step equation that we should be familiar with. We've got only one variable left. It's the x with the 2 in front. So after it, I have minus 2. The inverse of that is to add 2. So I'm adding 2 on each side, which gives me 10 equals 2x. And then to eliminate the 2 that's next to the x, it's multiplied, so I need to divide. So I'm just using inverse operations for those last two steps. So my final answer is x equals 5. Remember, you can substitute it back in. You can substitute it back in where the x's are to make sure that it's correct. This is not required. This is not required. This is just for the people who want to be certain they found the right answer. 5 times 5 is 25, plus 8 is 33. On the other side, 7 times 5 is 35, minus 2 is also 33. So I know by checking that 5 is the correct answer. Second equation, negative 3x minus 1 equals 5x plus 7. I'll circle my variables again and draw my line dividing the two sides of my equation. For this problem, the smaller variable happens to be the negative number. Negatives are always smaller than positives. So to cancel out negative 3x, I need positive 3x on both sides. Now the resulting equation is negative 1, make sure you've got the negative on that 1, equals 8x plus 7. Circle my variable again. So on the same side with that variable term, I've got plus 7. The inverse of that is subtracting 7. So I subtract 7 on both sides. 8x equals negative 1 minus 7 more. You're traveling further to the left, is negative 8. And then I can divide both sides by my positive 8 that was right next to the x. It was multiplied. And my final answer is x equals negative 1. Again, you could plug that back in and you could show that that's the correct answer. That's not required though. My next equation is 3x equals 9x minus 12. You may notice that this equation does not have as many terms. does not have as many terms. So when I circle my variables and I ask myself which one is smaller, it's the 3x, but I don't want to eliminate the 3x because it's the only thing on the left-hand side of my equation. If I eliminate it, there is nothing else on that side. And remember, you always want to keep your equations in balance. So I'm actually going to subtract the larger variable this time. So subtract 9x on each side. Remember, it really doesn't matter. It's your choice. It's just, I feel like you'll make fewer mistakes. You'll make fewer mistakes if you keep something on each side of your equation. So 3x minus 9x is negative 6x, and it equals negative 12. Again, make sure that that negative sign on the 12 goes with it. Then I divide by negative 6, divide by negative 6, and x equals 2. If I plug the 2's in, I'll show my check again. 3 times 2 is 6. 9 times 2 is 18. Minus 12, also 6. So I've solved it correctly. Our next example has decimal numbers. You can see decimal numbers or even fractions in these problems. So circle your variables. The smaller variable, because I've got 2 terms on each side, the smaller variable is 0.5x. So I'm going to subtract 0.5x. And remember, 0.5x is the same as 0.50x, which could be important if you're working without a calculator. So I bring down 0.7 equals 75 cents minus 50 cents is 25 cents. So here is my resulting equation. Circle my variable, add 6.3 to cancel out the minus 6.3. So if I add 0.7 and 6 plus 6.3, I get 7.0, which is just 7. So 7 equals 0.25x. So then if I divide by 0.25, what this is really asking you is how many quarters are there in $7? How many quarters are in $7? Well, there's 4 quarters in $1. So how many are in 7? 7 times 4 is 28. So x equals 28. And remember, you can use a calculator, so you don't have to divide those by hand. Our next example, we have 1.3x equals 3.3x plus 2.8. So more decimals. And this is another example where one side of our equation has only one term. So I'm not going to eliminate the 1.3x, even though it's the smaller one. I'm going to subtract the 3.3x instead because I want to keep something on each side of my equation. 1.3 minus 3.3 is negative 2. So negative 2x equals 2.8. And then I divide by negative 2 on both sides. So x equals negative 1.4. Our last example says find the value for x that makes the perimeter of each figure equal. And we have a triangle and a rectangle. A triangle and a rectangle. Well, the key word here is perimeter. So hopefully you remember that perimeter is the distance around. So the distance around a figure. Well, my first shape is the triangle, and my second one is the rectangle, and we're trying to get the perimeters to be equal to each other. So here's what I'm going to do. I'm going to add the perimeter of the triangle, and I prefer to add it like this. There are 3 sides. I'm going to put 1s in front of these plain x's, so hopefully you can see that when you add together the perimeter of the triangle, you will get 5x plus 7. 5x plus 7. Now I'm going to do the same thing with the rectangle. 3x minus 5 and x plus 4, but I need to remind you that there are 2 of each of those because the rectangle has 4 sides. Only 2 of them are marked because the other 2, the opposite sides, are the same. Opposite sides are equal in length on a rectangle. So we need 2 of each. That's a pretty common mistake that we see, that because they don't label all 4, you forget the other 2 sides. So now if I add these together, 3 plus 1 plus 3 plus 1 is 8x. Negative 5 plus 4, that would be negative 1. Negative 1 minus 5 is negative 6, and then plus 4 gives me negative 2. It doesn't matter the order that you add those in. If you prefer to add them in a different order, that's fine. Now I need to set these equal to each other because now we've got our equation to solve. So my variables on each side, I'm subtracting the smaller one. So 7 equals 3x minus 2. Then I can add 2, because here's my variable, add 2 on each side. So 9 equals 3x, and then divide by 3. And my final answer is x equals 3. Now I'm going to reread the question just to make sure, okay, I wanted to make sure that I answered the question because sometimes they will ask you to find the perimeters, not just to find x. So the value of x that makes those perimeters equal is 3. This is a connection to geometry, in case you didn't figure that out, and you will see a lot of problems throughout geometry that involve algebra. For your summary, here's a sentence starter. To solve an equation with variables on each side, please finish the sentence and explain our process.